Welcome to Easy Driver, the most reliable source of automotive information on YouTube. Please like, share, comment, and subscribe. In part 2 of our series, we're discussing the future outlook for automotive semiconductors and what's next in this rapidly evolving industry. Let's jump right in. Challenges in the semiconductor supply chain. The demand for automotive semiconductors is skyrocketing, but the road to meeting this demand is anything but smooth. Supply chain challenges continue to disrupt the industry, causing production delays, price increases, and missed opportunities. To tackle these issues, we first need to understand the root causes. Shortages and disruptions. Global disruptions have created a ripple effect in the semiconductor supply chain. These shortages aren't isolated, they stem from a mix of problems that have compounded over time. Pandemic-triggered delays. COVID-19 halted production lines worldwide, leaving companies scrambling to catch up. Manufacturing plants shut down, and raw materials became harder to source. Surging demand. Electronics boomed during lockdowns, with everything from laptops to gaming consoles consuming the same chips automakers needed. This left carmakers competing for scarce supply. Unpredictable natural events. Unexpected events like droughts and power outages at key manufacturing sites further slowed production. The result? Automakers were forced to pause production lines, leading to a growing backlog of vehicles waiting on critical chips. Geopolitical factors. Semiconductors aren't just a tech story, they're a political one too. Geopolitical tensions are reshaping how and where chips get made. US-China trade wars. Tariffs and tech bans have disrupted the import and export of critical components. Companies relying on Chinese manufacturers faced higher costs and longer lead times. Export controls. Countries are restricting semiconductor technologies to protect national security, further complicating global supply. Regional dependencies. The industry relies heavily on Taiwan and South Korea for chip production. Any disruption in these areas, whether political or environmental, sends shockwaves across the supply chain. Geopolitics has turned semiconductor sourcing into a balancing act, forcing automakers to rethink where they get their chips. Manufacturing capacity constraints. Even before the disruptions, semiconductor manufacturing was already stretched thin. Building new facilities takes time and billions of dollars, meaning capacity issues can't be solved overnight. Limited foundries. The world's leading fabs, like TSMC and Samsung, are operating at full capacity. Expanding production takes years. Complex production process. Chip manufacturing involves hundreds of steps and precise engineering that can't be rushed or easily scaled. Focus on high-margin chips. Foundries often prioritize consumer electronics over automotive-grade chips due to higher profits, leaving automakers short. When demand surges unexpectedly, these bottlenecks make it nearly impossible to produce enough chips to meet the industry's needs. Future outlook for automotive semiconductors. As the automotive industry races toward electrification, automation, and connectivity, semiconductors are taking center stage. The demand for smarter, faster, and more efficient chips is only intensifying. What's next for this essential technology? Here's a look at the future shaping automotive semiconductors. Technological innovations on the horizon. Emerging technologies are poised to redefine how automotive semiconductors work, making vehicles smarter and more capable than ever before. The industry is innovating at a relentless pace, leaving room for groundbreaking advancements. Advanced node technologies. Chips designed with smaller nanometer processes will offer better performance and lower power consumption. This is critical for EVs that rely on efficiency for range. Silicon carbide, SiC, and gallium nitride, GaN. These materials are gaining traction, especially in power electronics, delivering higher efficiency and durability over traditional silicon. SiC chips, for instance, are expected to dominate EV inverters and onboard chargers. System-on-chip, society, designs. SoCs will integrate diverse functions, AI processing, communication, and sensors, into a single chip, reducing weight and boosting performance. Looking further ahead, quantum computing concepts and neuromorphic chips could enter the space. Though still in research phases, these technologies promise leaps in processing power that could revolutionize autonomous driving systems. Predicted growth rates and market dynamics. The automotive semiconductor market is on a sharp upward trajectory, driven by the rise of EVs, ADAS, and connected tech. Analysts estimate compound annual growth rates, CAGR, hovering around 8–10% through 2030. This growth is being fueled by several factors. EV market expansion. EV sales are expected to account for nearly 30% of the global automotive market by 2030. This surge will require a significant jump in semiconductor output. Increased semiconductor content per vehicle. Modern cars already use $300 to $500 worth of chips. That number could double for EVs and autonomous vehicles. Automakers are now designing vehicles around advanced electronics rather than mechanical systems. Shift toward vertical integration. To stabilize supply chains, automakers like Tesla and General Motors are investing in in-house chip development or partnering directly with fabs. However, the market is also navigating challenges. Supply chain bottlenecks, geopolitical tensions, and competition for wafer production space continue to loom. Addressing these will be key to sustaining growth. With constant innovations and rising demand for chips in EVs, autonomous systems, and connected vehicles, the future of automotive semiconductors looks bright and demanding. The question isn't whether the market will grow, but how the industry will keep pace. Please comment, like, share, and subscribe for more automotive information like this. Thank you for watching.